very pleased to welcome Gilles. So on top of being a very good friend, he's also one of the best experts in the JUWI industry in South Africa. So we have a very large knowledge from utility scale, CNI, residential, having a position in technical department, entrepreneur also, I think, business development in Africa. So we have really a lot of experience to share with us. So I'm very pleased to welcome him today, and it's a great pleasure. And thank you very much for your time and for your to present this to our team. Gilles, the floor is yours.
Okay, thanks. Good morning, everyone. Just a quick introduction from myself. So my name is Gilles Dumont. I'm also French, Sebastian. So I've been in South Africa for about 13 years now, even more, 15 years, sorry. And I've got a master's degree in engineering, and I joined in and worked on the CNI sector for 7 years. So I started in 2010 in renewable energy sectors, starting rooftop installation and stuff in the CNI for a company called Emergent Energies, if you guys know them. So it's still ongoing. And then after the company got sold to another lenders or the funders, and I moved to the IPP division with Biotherm Energy in Johannesburg for just over 2 years. And that's where I actually exposed myself to the whole of African continents. So I worked in Burkina Faso, Nigeria, all of these funny places. And then I've been now for JUWI, working for JUWI Renewable Energy, which is an EPC company, for over 3 years, and I'm the head of the business development team for them. So I've got the whole spectrum from basically rooftops, residential installation, to IPP and financing of projects, and now construction of large-scale utility projects. So that's me in a nutshell. Now I'm going to present a bit more about JUWI, I guess. If you can see, you can see. So JUWI is an international company. Head office being in Germany. We employ over 1,000 employees globally, and been around since 1996. So that's one of the oldest EPC company that you can find on the markets. So we're doing in also product development. So we do from greenfield developments to shovel-ready projects. Then we contact IPPs or different funders to get financing of the projects, and then we execute the project and do the operation and maintenance. Our office is based in Cape Town, in South Africa, and we cover the whole African region from here. So just to give you a bit more explanation about the key project that we've done in Africa. So we've done 3 major projects in round 4 of the REAP program, over 240 megawatts in South Africa. We've done, so in total in South Africa, we have about 400 megawatts of projects complete. And the 2 other projects that's quite, a bit different and important to state is a project in Egypt, which is Sukari Gold Mine project. It's a project that includes PV and BESS integrated to a diesel HFO engine. And that's basically the largest hybrid project on the African continent at the moment. And then the other one is a Evander project, 12 megawatts, which was the first project behind the meter on the mine site in South Africa, which got their own challenges. You're basically now not working on a greenfield, but you're working on the brownfield environments. So it's like dump sites that we refurbished, and we dig out all the soil contamination. And then we build PV plant on top. And it was the first one to get grid code compliance from ESCOM. Over 1 megawatt project, there was ESCOM regulation for project under 1 megawatts and over 1 megawatt. So it was the first one to achieve that. So that's what we've done in Africa. Other key hybrid projects to show you what we're doing as well in Australia. So in total now we have 14 sites in operation which are hybrid projects. So when I call hybrid project, can be a combination of any size, any type of source of energy. It can be solar, wind, batteries, diesel, and we integrate that. So we've done quite a lot of projects for the mining sector in Australia. The reason for that is Australia, there is no large utility grid. So most of the sites are actually remote and completely off grid. But we also did that for a project that you can see here on the map. I don't know if you can see my project Esperance, which is actually a municipality in Australia, where we've done 9 megawatt wind, 4 megawatts solar, and 5.5 megawatt BESS integrated to the gas power plant. So that's for a municipality. So that's something that's what we can call microgrid installation. So that's JUWI in a nutshell. what we do and what we're focusing on. So that's all our existing customers. So you can see there's quite a lot of mining clients like Rio Tinto, Centamin. So Centamin is the clients in Egypt. Pan-African Resources is a project in South Africa. And KPS, or basically kind of developers and IPPs, and EON as well. And now we're doing project in Africa for 2 new clients that are not on this list. And Sandfire is a project that we're going to do in Botswana as well. So I want to focus a bit more now into maybe the mining sector and the decarbonization goals. So as you know, there is a big decarbonization plan globally. And so what's happening is a lot of the minerals which are actually mined mainly in Africa or Asia, or actually sent to Europe or already United States or developed country for them to do, I don't know, manufacture cars or manufacture any processes. So what's happening is all of these European or developed countries to decarbonize. So they decarbonize already the operation, the facility, the factories are already decarbonized. So there's three scopes of decarbonization. So the first scope is you need to decarbonize your power, your factory. Second thing, you need to decarbonize your source of power. So as Europe, you got nuclear and all this type of source of power. So it's already kind of advanced in decarbonization. And the third scope is basically you decarbonize your supply chain. So whatever you come from raw materials. So that's where the mines come in operation, because all of these mines are EV fuel consumer. So they actually have a lot of carbon impact. So the way they do that, so they all have to meet certain targets for a couple of reasons. First, to be able to meet the global requirements. Secondly, to try to sell the minerals for a higher price. Because if the minerals is stated as green minerals, then they go for a higher value. So there's different, all of these mining clients that I'm state basically have to get the operation net zero targets by 2030, 40 or 50. So that's basically, it's a massive, it will have a massive impact on the global view of renewable in general. When I speak about operation, it's basically how they process the minerals to export it. So basically you can cover a source of power for the processing plant. You can also cover the trucks that they use for the machinery. You can cover everything that they import, even themselves, as raw material for the mining industry. So that's in a nutshell. To give you a renewable vision of mining. So mining accounts for about 10% of the global CO2 emission. So that's a massive impact of the CO2 emission. So that's why it's quite important for them to, or for the world entirely, to actually decarbonize. So to give you some value on the left graph here, so on the left here, so that's the amount of renewable solar and wind installed in the last 3 years. So you can see we install about 100 gigawatts per year on solar and a bit less on wind, and it carry on growing slowly. You can see a slight reduction on the wind in the last few years, mainly due to supplies and cost of transport and logistics of all the wind turbines globally had a major impact on closing the project. So what does this impact if we want to actually decarbonize all of this by 2050? So that shows you a bit more or less the total global installation of renewable to date. And by 2050, you can see we need to have basically an 11% increase yearly in terms of installation of renewable energy per year. So it's quite a lot, and it's going to put a lot of strains not only on suppliers, on manufacturers, but also on mining sector itself, because a lot of the minerals like steel, silicon, copper, aluminium, everything that you can think of a power plants actually come from a mine at the beginning. So it's going to have a massive impact on them itself. So yeah, so there is different drivers, as I mentioned. So energy transition, low carbon, critical material required at scale. One other thing that I didn't discuss is the reliability and low cost. So a lot of these mines need to have a reliable source of power. They're running 24/7. So they can't have a drop down every minute that the power is not there, then it's a loss of revenue for them. Because they can't just shift the production. It's 24-hour operation and they can't increase the load for a certain amount of time. So then financing, you have to get access to capital to actually implement these renewable energy projects. And the governance is the one that I mentioned. I mean, CO2 risk emission is a massive risk for them. And the supply chain risk, as I mentioned earlier, is going to have a massive impact on supply chain. The more you're going to have to need this material for the renewable energy sectors. Just to give you a bit more insight about the energy consumption of a mine, or the energy needs of a mine. So basically 55 to 90% of electricity consumption is needed for mining sector. So that's a quite heavy percentage of the total operation emission. Diesel and others are quite smaller. So in South Africa, you know, it's a massive impact because all your energy, even though it's come from Eskom, it's carbon emission because it's coal power plant. So you need to decarbonize this quite a lot. So if you can provide 100% renewable energy from a combination of source of wind, solar, and batteries, then you decarbonize up to 50 to 90% of your carbon emission in South Africa. So quite a massive impact. Just to show you some case studies. So what we've done in South Africa, that's specifically for a platinum mine actually in South Africa, where the yearly consumption is about 286 gigawatt hours. And you must remember, as I mentioned earlier, this is a flat load 24/7, except for the 2 weeks of heavy maintenance that they do in December. Otherwise, the rest of the year they operate 24/7 at full load. So what we provide to them as a solution is a combination of 35 megawatts solar, 35 megawatts wind. You must know that this is sized to actually avoid any curtailment of power or minimize the curtailment of power, because their actual maximum demand is about 31 megawatts or MVA 24/7. And that basically only, without any battery, gives them about 65% renewable energy penetration. So as you know, source of power for solar in South Africa is quite good, so that can be on site, anywhere on site. But when we start implementing wind, you need to find sites which are remote, and then you're going to have to use Eskom for wheeling power. So it's quite tricky because now you got Eskom involved, and you got wheeling agreement involved, and you got government institution involved as well to agree your PPA or your transport of power. Then we run another simulation for them. So the same size load, and we say if you want to go to 100%, almost 100% renewable, you need to actually move your double your PV and double your wind. That will have a massive impact in terms of the carbon emission, but that also will have a massive impact on the cost of electricity, because if you do this maximum power, you will have a lot of curtailment, so your price of electricity will go up because someone's going to have to pay for it, and the developer is not going to pay for that. Okay, just to give you a system power overview, so that's how we design, for example, plants. So we have a combination of thermal power plants, wind power, solar power, batteries, to be confirmed on these cases here, if it's Sangro or SMA. We normally use with major suppliers, so you can name the different suppliers of panels, Centec, JA, Jinko, Canadian Solar, all these guys. In terms of wind turbine, we normally work with a top tier as well, Goldwinds, Gamesa, Siemens. And the battery supplier, we normally work directly with the supplier itself, or SMA, LG, Saft, and all of these guys. And then we provide basically a whole solution. So we integrate all of that for the client. To get in consideration, basically the microgrid controller is the most important tools when you have a combined source of power, because not just the pure PV that you connect to your DV board. You need to take in consideration what your load's going to be, what your future load's going to be, what the weather is going to be like in the next 24 hours, to actually see how much you want to charge your battery or discharge your batteries, how much your wind production is going to be. So it's basically your brain of your whole system. If you don't have that right, then you are up for failure. And then if you have a failure, then the mine can't operate, and then you have a massive impact. And they can terminate your contract, and then you can't. You can put the key under the door and leave somewhere else. Yeah, it's quite, I mean, the guarantee that we have to put on this contract is quite heavy. So we have to guarantee a certain amount of energy per hours per day, certain fuel reduction. If you have a remote site, we have to confirm how much fuel savings they're going to make. So that's quite heavy on these scales projects, much more than what you have, for example, on small CNI PV rooftop installation. Just to give you an example, so that's the same project that I mentioned earlier. So the simulation that I had at the beginning, which we had 286 gigawatt hours production per year, that relate to 37 MVA, 31 megawatt average. So as mentioned earlier, you can see on the left graph here, the nice thing about having multiple sources of power between wind and solar is you got different profiles. So on the gray graph here, that's your standard tracker solar production. And on the yellow one, that's your standard wind production. So you can see the wind production is much more at the dawn of the day and in the morning. The solar is more during the day. So a combination of two actually allow you to have a higher renewable energy penetration with having batteries required. So you can see, for example, here the blue graph shows a combination two, and you can see we're curtailing a bit of power here on that portion of time, that's on a good day of production. Some production you will have no curtailment at all. So we size the project to that, and we do a yearly average of what the yield will be. So how we do that, we buy actually satellite data for the solar irradiation, and we actually have wind campaign measurement outside of the wind capacity of the wind farm and a model according to that. So give you, for example, here this simulation give you different term of PPA. So now this is a bit, an old presentation. So we are only giving 15 years and 20 years PPA price indication. Now with a new market coming in South Africa with open of trading power and having more offtake for power, we can see now PPA all the way down about 5 years or even 2 or 3 years sometimes. So the lenders are happy to follow you if you have a set amount of years of PPA. And now they can see back in the day was 20 years. Now we can go 5 years and even below that. So there are multiple reasons for that. As I mentioned, the market is opening up. There is trading platforms coming up. That's what we have in Europe, for example, 10 years ago when we start to open to a more open markets. So anybody is going to be able to buy power from anyone. So you're going to have people coming and knock at doors like, I will sell you power for 5 years at that price, and you can change the contract and go to someone else, like you are nowadays with your cell phone or your banks or whatever. You can change right, left, and center. So it will be coming now, everything. So yeah, so Eskom will approve any PPA, will approve the PPA, but they don't mind what the term of the PPA. Yes. But it's not always city municipality. If you're connected to municipality or not, it depends. If you're not connected to municipality, you're already Eskom. But both of them should approve the PPA. But if you say I only have a PPA for, they can't stop you.
But they still benefit on some of the mix.
Yeah. And I don't know if you guys are aware, they also Eskom released recently now the new standard offer program. They give 5 years PPA to anyone who wants to build a plant, and they will buy power at a certain rate for 5 years. So let's say you have, for example, a PPA, a 20 years PPA with one of your clients, and you have excess power. You say, I don't know what to do with this power. You can 5 years PPA with Eskom and say, I'm going to give you that amount of kilowatt hours for 5 years, and they will buy it from you. So it can help you in your financial model if you have this. And we're actually doing that now for a lot of sites and existing projects which already have grid capacity. So, the issue in South Africa, you probably don't have grid capacity, but if you have grid capacity already, but you have excess power, then we're trying to revamp some of these plants and add more power in plant to be able to sell this power into that 5 years PPA with Eskom. Okay. So another way, so first portion presentation, or mainly the whole of presentation was about decarbonizing and source of power, but the other option that the mind are looking at now is all of this carbon neutrality, and what I mentioned at the beginning is the fleet of trucks that they have. So you can see an old fleet of trucks on the mining sector will use about 1 billion liter per year of fuel, and that would be 16 terawatt per hour. How do you decide these things now? So you've got multiple options. You can have hydrogen plants and provide trucks hydrogen that we can cover for this example. If you put 1 gigawatt of renewable energy plants, solar plants, you can have a catalyzer and provide hydrogen, and that will be 42% of your fuel consumption will be covered by that, and 18% will be on the completely battery vehicles. So that's another way that the mine are looking. There is no major plants or major mines are actually implemented on the large scale at the moment. The first hydrogen, I think it's in Anglo-American mines in South Africa. That was the first one that was implemented. And we see a big rollout of this. So that now opens the door to a new market. It's not purely PV and wind to generate power, but it's some PV and wind to sustain provide hydrogen, and then you have hydrogen trucks, or to charge batteries that you can interchange like you have on your electric cars now. That opened a new channel of markets for people like us, which are build plants.
How does the mining chemicals affect the efficiency of the panels and of the clear? Obviously, there's a lot of mining dust depending on the type of mining. How does it affect the efficiency of the
So how it works, it doesn't impact the efficiency of your panel if you clean your panel regularly. So what we normally do, you have a soiling factor on all of these plants. So normally we simulate all of these plants on mining sites to increase your soiling losses. So if you'd already put in your simulation, you say I'm going to have more dust than normal. So I'm only going to guarantee to the client a low amount of energy that I will do in the remote places. And then on top of that, then your end costs actually go higher because you actually have to clean your panel more often. So you are trying to cover yourself a bit more. But the integration of the pan itself and the integration of the structure is designed to sustain this ash or whatever.
So your normal standard panel that we saw here,
yeah. So there is no issue with guarantee on that. Yeah. I don't know what you supply here, but I hope so. Okay. And that's it for my presentation. I mean, I hope you like it. If you have any question, please shout.
we don't have to party from part to part for this type of system. We don't have the capacity to design the type of system because you obviously need a lot of others, like your scopes, what is required. Personally, I don't have all the technical way to do that. But if we get sort of size system like from a client request, would you facilitate kind of
I mean, it depends on the plants. We normally don't touch anything below 10 mega size projects. Yeah, it's pretty linked to a capex issue to make sure our revenue margin. But I mean, there is consultant that can do the design. I mean, we quite a lot with Sutari or Konix, so these guys they can actually do simulation. But now, if you look at smaller guys on the CNF, like dormant projects, for example, they can do this type of simulation for you. ACES Africa can do this type of simulation for you now on the, let's say, from 1 to 5 megawatt, they can do this type of simulation. And I heard now there was a massive battery project happening in Cape Town from MD, Solar MD. They do that one, so this type of guys, I guess, would be able to assist you with them on this simulation as well. Tools we use internally, so we have our own software that we developed to do the sizing. But at the beginning, we were using the software like to do our first base simulation. But that's good when you have just grid and batteries or solar. But when you start to have HFO engines and the integration and the SCADA integration of that, you need your own software to develop to do that.
So in your mining activities happen up in the northern Cape Town regions, because it's where 80% of the mining sector. Your sort of summer days, they experience a lot of their season. So what you expect earlier on with the different sources of energy in order to feed the mine. So you're able to do their prediction studies to know exactly what sources are from, and able to feed into the grid.
Yeah. So what we do here in South Africa now, because we don't even have land available next to the mine, so we can have a PV plant. Let's say your mine is in the Northern Cape, you can have a PV plant in Northern Cape, another one in Limpopo, wind farm in Western Cape, and then you actually get all your power prediction from there, and then you say you're going to use work, and that's what the power is come from.
And what is sort of the average implementation time and resources involved to execute a project?
Depends on the size,
If you take a 10 meg,
but
Development and construction.
yeah. Oh, development and construction. Development gets anything from, I mean, on 10 megawatts, you probably can go development. Your longest it will be your EIA. That will take, or the 10 megawatts you might do with a basic assessment environmentally. So that will do 6 to 8 months. And then you do all the other permits in the same times. You need to start your ESCOM process, see estimate letter from ESCOM and DQ process that can take you from 6 months to a year. So let's say from development, you'll be safe on the 10 megawatts and implementation about a year as well.
and what's the implication of a scale of that to the system like that? And obviously the payment is not like somebody buys the system, so obviously different financial model attached to the system.
Yeah, so a pure 10 megawatt project, depending on the site condition, because it depends, I mean, the major cost driver will be the site conditions. If you have a lot of civil works or not. If you have a lot of civil works, you can go all the way to 250 million rand project just for a 10 megawatt PV without batteries, without anything. We're doing one now in Barberton for Panel Resources, which cost about 250 million rand, just for 8.75 megawatt AC and 10 megawatt peak. But it's a brownfield site, so you have to dig out the sites, remove, there is plastic, rubber, there is everything there. You have to flatten it up and then put this thing on top. If you use on the greenfield site, which is clean, you can go down to below 200 million. Yeah. Don't be upset.
Can you explain us the difference between developing a project for the area you have a simple take or pay versus a project that you have now to provide energy to offset the load? And in the scenario, what is the advantage of having peak and wind combined versus only wind? Why, in fact, is combined as a source technology to basically be effective as possible to offset the load?
Yeah, as I see, I mean, that's probably what you got in that graph here. So when you have a kind of different source of power, you get the best covering ratio of renewable energy is your load. So especially for mines, I mean, not necessarily for shopping centers and stuff like that, when most of your load is a day, but when you have a 24-hour operation, the nice thing of combining multiple sources of power is you get a source of power coming at a different time. So you can actually provide power for a longer period of time. And if you provide a higher penetration, then you will cover a bigger chunk of the day, and then cover your peak hours. Basically, your morning and your night peak hours. So you can provide this at a much cheaper rate than what ESCOM is charging you. So the benefit for the client, you will save much more money. Yeah, you put less battery as well, but yeah, you into it. But I mean, for us, it's the bigger the product is, the better it is. And for the client, bigger the product, or the wide range of hours that you're going to provide power, the better financially it is for them. Because during off-peak time, PV are not really competitive with ESCOM pricing today. But during standard and peak hours, then actually you get most of your savings there. And your wind, as you can see here. Your wind that's from 5 to, 5 is here and 8 o'clock is here. So that's all your night power is coming from purely wind. And the wind power at 60 cents compared to a 330 that you pay, that's a massive saving.
But what type of battery pack would be put in there? That's not your standard low voltage.
No. Yeah, so we put, it will be all medium voltage output. So it's 33 kV. So that's in a nutshell. I mean, there is a lot of things go into all of this simulation, obviously. I mean, being on off-grid changed everything as well. So you have to take this elevation. But yeah, one thing that won't really see in that presentation is the guarantee level and the performance level that you provide on all of this project is quite heavy. So we don't see that too much. I mean, coming from the CNI when I was before, you say, okay, I'm going to provide a thing, but there's no really penalty mechanism that put in to actually penalize the EPC if you don't provide it. On this type of contract, if you don't provide 1 kilowatt hour, then you get penalized for it.
You have to guarantee solutions.
Yeah. So you have. That's why I say simulation is a big thing, and you have to say, okay, that's my design. You get a buffer for your guarantee level, and you get another buffer for the minimum guarantee required to the client.
So the full sources of energy is your redundancies.
Yeah. Could be.
There's no dependency on this.
There's no dependence on ESCOM.
Yeah.
What do you mean?
That's not the source.
You always, I mean, all of this simulation, you always depend on ESCOM to provide when you don't provide any power.
But in something like the mine setup, there are some of the mines that have absolutely no ESCOM.
Yeah, then you could be completely off grid. Yeah. So this project, I mean, the Sukari project we've done is completely off grid. There's no network. But then it's got HFO or fuel engines, or thermal power plant that will supply your base load. So how does it works? Basically, normally, let's say back in the days, there was only HFO thermal power plants, and they will provide your load. Now what we do, we're trying to integrate solar, battery, and wind into that things to let you switch off engines or make them run at a more efficient level. So we have to do all of this simulation. So let's say you have, sometimes they will have 10 engines. So okay, during peak of the day, when you have tracker heading and base or charge, then you switch off, let's say, 4 engines, and you run the other one at the idle load factor.
But that process is
all done by the SCADA system that I mentioned at the brain of the system. If you don't have this right and you command, because you have from this small, it's a small box, it's about the size of my phone. And that box basically control everything. It sends signal to say start, switch off, the weather is check the weather, it says it's going to be like that, my battery are not charged enough. Similar. The thing is now is take in consideration all your engines requirements as well. These big engines have a ramp up time, load factor. So you have to plan in advance to say, okay, you have to switch on because you need to give me power in half an hour time. So that's the type of thing that you need to consider.
If you can explain a little bit more, just to make sure that the difference between I do the CNI, I guarantee the performance of my plant for 1 year, 2 years, or maybe more after we see maybe the availability, and I guarantee the kilowatt hour. Just to make sure everybody, the people can understand the impact, maybe the risk that you have to integrate as a developer and as a...
Okay. So we send this large EPC contract. There is various guarantees to provide. So there's a test on completion, first of all, that you need to apply with. And your test on completion will consider a whole bunch of tests, but the 2 major requirements will be to have a maximum export capacity that you have to achieve. So let's say you'd say upsizing my plant at 100 megawatts AC. You need to provide the client the proof that you can actually export 100 megawatt AC. The client, I'm not even speaking about ESCOM yet, the client. So if you pass that test, then you pass the first. Then you can say, okay, my plant is going to perform at 87 performance ratio. If you guys know what your performance ratio is, but yeah, your performance ratio. Let's say I design 87 on my report. I guarantee 85, for example. If I don't meet the guarantee, then I have to pay performance liquidity damages or whatever is below the 87 and if I don't achieve minimum PR, which is even lower than that, then they can reject the plant completely. So they can just, okay, I reject the plant, pack everything away, and you take it. So that's the first thing. And when you connect it to ESCOM, you need to pass all of this to be compliant with ESCOM grid codes. So you need to prove to ESCOM that whatever ESCOM is going to send to your plant, you're going to be able to achieve. So ESCOM is going to say I want your plant, doesn't matter what the load is, what the client needs, everything. You say, I want your plant used from 100 megawatts to 10 megawatts in second. You have to prove them that you can do that. you have to show them that you can up and down at any type of signal at the same. So you have to communicate, all of these plans have to come with ESCOM network. Yeah, and if you don't pass the test, then you actually should switch off and completely. I don't know if you remember, long time ago, there was this, Molofia project that was done by SolarF or something, and they've been back and forth with retech testing and ESCOM testing for a long period of time because they comply with the grid code compliance. So they couldn't switch off the plant when ESCOM was asking to switch off the plant. They couldn't reduce the power output when ESCOM asking them to send the power output. So that's why they actually achieved, and now you have to install a new controlling system and communicate. So when you speak about everything above this one, but now you enter a new scale of category of project. I mean, there is category A, B, and C plan from ESCOM. So most of our projects that we have category C, which is all higher requirements. So you have to comply with all your critical compliance. And on top of it, the Pan-African resources that I mentioned earlier was the first of its kind behind the meter. It was not even a grid code right for this thing. So we have to actually write the requirement with retech and ESCOM to comply. That's answer.
No, and that's why you cannot do this for small product, because imagine the quantity of work. It's that you need a minimum size to make it viable.
Yeah. Other question?
So, in terms of wheeling, why do a lot of these projects get all the way up to 90 to 96% and just abandon because it's not feasible anymore? Why did you do a feasibility study beforehand that's accurate, or can you tell us what the reasons that these projects never come to fruition?
On big projects, on winning big projects. I mean, there is various reasons. I mean, first thing, or I've seen from my experience, is this project long time. So sometimes you do a feasibility study, and you have a snapshot of what the cost and implication of this project will be today. Your project will take 2, 3 years, 4 years to develop. The assumption that you took at the beginning are not more. Because your cost of your plant may increase, your cost of your interest rate may increase because you have to get someone needs to lend you some money. When you have an assumption is you're going to have a rate of investment at 8%, and 4 years down the line is 15%, then you can't financially close this project anymore. The reasoning and the thing is that's one of the main reasonings. So the question is more about why does it take so long to get there, and most of the on ESCOM delay, grid capacity not being there, and ESCOM providing access to grid quick enough. That couple, I mean, because you all know the network there is nothing. So sometimes you do an assumption, you do a simulation, you say, okay, there is capacity, there is things. By the time you actually follow the queue of ESCOM, there is no grid capacity anymore. So now ESCOM is going to say, now if you want grid capacity, you need to change your scope of work. You need to build me 20 kilometers of rail line. You have never thought about it at the beginning. So that's the reason. The main reason is the timeline of the project. Yeah. At the end of the day, the cost and the financial model. So even let's say yours doesn't necessarily change, maybe your financing terms change. Okay.
Just a question from my side. In terms of component failure,
Mm-hmm.
in the duration of how's that handled?
Okay. I mean, it's a broad topic. I mean, so a lot of, I mean, there is component and share and everything. So what we provide, we have to provide notification period for 2 years. So whatever failed for the first 2 years, it's our risk. And we have a back-to-back with most of the suppliers. So if there is, so we have spares on site, and then every time there is a failure, if it can't be repaired, it will be sent to the suppliers, they send us a new one. That's for the first 2 years. And then everything after the first, if we hand over the plant to the clients and we don't do the O&M anymore, then they will have warranty that will for this project. So all your structure is guaranteed for 10 years, all your inverters is guaranteed for 5 years, and your panels got production guarantee of 20 years. depends from project to project. Depends on your supplier mainly. If you have the right suppliers, the failure is very low. We did use supplier in the past when we had to change, for example, all the panel on site. So basically, all of this contract will have a serial defect amount. So if you have a certain amount of defect on one component, let's say you have 1,000 panels. If you reach 5% of defect on the 1,000 panels, you replace all the panels. And we have them on our site, we have to replace all our panels. But that's a back-to-back again with suppliers, so they have the same guarantees. Same thing for structure, same thing for inverters.
So I could assume that the process of getting suppliers is
Yeah, that's key. That's why we don't, I mean, we have a whole head office in Germany that's actually we are testing. So not only, so this vetting quality, production lines, but also ethical, forced labors, financial, all these type of things are covered in there. You don't want to deal with a company that do business with, for nowadays, with Putin, for example. So that, no, but it's true. I mean, that's the thing, because we have to, our clients force us to have anti-bribery clause. Everybody that we employ in our project have to complete a clause. So we can't, the supplier, if the quality is good and the product is good, but they do something with the wrong person, then we can't. So a constant change of suppliers. So it's not we have one supplier and we stick for it forever. I can give you a good example. At the moment we were using, I think, Game Change as a tracker manufacturer. And they've now been out of the list because the quality control of the factory didn't pass our requirement.
These requirements as they being put to suppliers.
Yes.
Is it imposed on a month, on a 6 months, year basis?
So we do a yearly visit to all our suppliers.
Yeah.
So we inspect all the factory area. So it can be good this year, and next year you can not pass the test. And that's another reason for, our internal cost is quite high, because you have to accommodate for that cost in the project size. So if you do a 1 megawatt, then it's not worth it. Yeah, but it's also kind of, your clients can terminate your contract if you sign a contract with someone which is linked to bribery. So you can actually use all your money. It's not even a peace of mind. It's a financial impact. It's a fair impact. Yeah, go ahead.
If you were to design this from scratch now, brand new now, and you had a choice between hardware and software components, which one would you choose?
What is project?
Let's say 1 megawatt. 1 megawatt.
I mean, that would be a 50-50, to be completely honest, on that scale project. And, our preferred suppliers at the large-scale project are Sungrow, not necessarily because of price or quality. It's because sometimes you have to play with a deal that you know that the one that you don't.
So, your opinion is better than the other?
I mean, the Huawei and Sungrow product are very similar, and they're both good. Even Trina have the same type of solutions. So the three are quite good, but we've done a lot of projects with Sungrow in Africa and Australia, and we know the service is good. And we know what the issues. If you're now changing to someone else, and you don't know what the issue could be, then you open yourself to another. So it depends how, first if the client is a specific supplier, and it depends if you willing to take a risk on having issues on the new suppliers.
So integration is not necessarily an option to discuss. On warranty and the match integrate into an existing solution.
So if the
if your existing system,
Yeah.
you want to take a different type of solution for functional use, but you can back it with the warranties and support that comes with it. That's not necessarily an option to discuss in projects like this.
No, I mean, if you already have them in place that already have Sungrow, you're not going to put Huawei in.
If for some reason, obviously with some of these on a larger scale, you cannot always get all the equipment with a time factor to it. If there's a deadline to have an alternative solution, you that be some discussion?
If it's a time issue and you have no other option, then you can consider it. But we're not integrating multiple, inverters or MV station, PCS, then the communication has got to become an issue. No, we have example. To give you a good example, we're doing a project in Senegal for mining clients which are HFO engines, and they only have ABB switchgear, and communication already on with ABB. So all our ERs and our integration have to be ABB because it's easier to communicate with. And you don't have a conflict of interest in terms of which signal you send to this one is a different signal that you send to that one. So it makes life easier. I'm not going to be done, but it's not ideal. Yeah, the thing is, the more people you get on one side, people start to blame the other. So if you start using a Sungrow and a Huawei, you say my inverter can't work because Sungrow is sending, the wrong harmonics into the system, then my inverter can't work. And the other guys will say the opposite. It's the same thing what we have sometimes. For example, we had a failure on panels. Panels are black glass is cracking. And the manufacturer of the module is the tracker guys. The tracker guys say it's the guys who installed it. And then, it's a circle like this. So you can never find, if you're starting too many people involved, then you make your life even more difficult as an integrator.
Thank you.
Sure. I don't know, I switch all these settings.